children, take up the geography book. Today's topic is anti-trade winds of westerlies. The westerly winds which blow with great frequency and regularity in regions lying on the polar sides of the subtropical high pressure areas or horse latitudes are known as anti-trade winds of westerlies. The areas in which they blow are often known as the regions of the westerlies. The prevailing wind direction of the anti-trade winds in the northern hemisphere is from the southwest and in the southern hemisphere from the northwest. In winter, they move southward due to shifting of pressure belts in the northern hemisphere affecting the Mediterranean regions, bringing winter rain to this area. These winds derive their name from the prevailing direction. They blow opposite to the direction of trade winds and are thus known as anti-trade winds. The weather in these areas is marked by almost constant depression and anticyclones moving eastward. In winter, the North Atlantic Ocean is probably the stormiest regions of the world at any season, but in summer the winds and weather are much less violent. In the southern hemisphere, on the other hand, the westerlies blow with great strength and regularity throughout the year between 40 degrees and 50 degrees south and have been given the name Roaring 40s and Furious 15 because they face almost no obstruction. The polar easterlies, a belt of easterly winds blowing in a zone between the westerly depression tracts and the polar high pressure belts. They are generally of low velocity. From the polar areas, cold air tends to move equatorward. This movement is pronounced in the southern hemisphere. As the air moves equatorward, it is deflected to the left and so a belt of winds resulting spiraling from the polar region in an easterly direction. These polar winds are extremely irregular. These winds are extremely cold. In general, in the northern hemisphere, they blow from northeast, whereas in the southern hemisphere, from the southwest. Seasonal shifting of pressure belts. The Earth revolves on its orbit around the Sun in 365 days. The Earth is inclined on its axis at an angle of 23.5 degrees. Thus, the relative position of the Earth with the Sun changes. In consequence, the positions of all the pressure belts change with the northward and southward migration of the Sun. At the time of summer solstice, the Sun is vertical over the Tropic of Cancer, June 21st, and therefore all the pressure belts except the northern polar high pressure belt shift northward in northern hemisphere. The equatorial low pressure belts prevail between 0 degree latitudes to 10 degree north latitudes and the subtropical belt extends between 30 degree and 40 degree north latitudes. Thus, all the wind belts associated with the pressure belts also shift northward. The Sun becomes vertical over the equator at the time of autumnal equinox, 23rd September, and hence all the pressure belts which shifted to the north occupy their normal position after autumn equinox. There is southward migration of the Sun which becomes vertical over the Tropic of Capricorn at the time of winter solstice, December 23, and hence the pressure and wind belts shift southward except in the southern polar high pressure belt. Thereafter, the Sun is overhead over the equator at the time of spring vernal equinox, 21st March, and hence all the pressure and wind belts occupy their normal position. Thus, there is a shifting in the position of pressure and wind belts due to seasonal changes of position of the Earth in relation to the Sun. The seasonal changes in the relative position of the pressure and the wind belt influence the areas of the Mediterranean climate and the position of the westerlies which move northward in the summer season and southward in the winter season. The summer wind, the monsoons and the complete reversal of wind direction are also the results of shifts of wind and pressure belts. Both the trade and anti-trade winds are thus closely influenced by the shift in pressure belts. In addition, high-speed upper atmospheric pressure currents known as jet stream and occasional atmospheric ocean currents coupling event known as El Nino also affects the permanent winds in subtropical latitude. Jet stream. Jet stream is a strong and wind blowing from the west to east at high altitude, usually near the level of the tropopause. The jet streams normally are 160 to 480 km wide by 900 to 2150 meters thick, with core speed that can exceed 300 km per hour. The speed of jet stream varies from a mean of 110 km per hour in summer to about 190 km per hour in winter. The main types of jet streams are: number 1, the subtropical jet stream; number 2, the polar front jet stream or middle latitude. The jet streams of subtropical latitudes is more steady as compared to the polar front jet stream, owing to the transitory thermal contrast of this latitude. The Arctic jet streams and the polar night jet streams are, however, weak and less steady. The velocity and location of the jet stream has an important effect on the travel times of high-flying aircraft, especially in mid-latitudes. El Nino. El Nino is the name given to the occasional development of a warm ocean current along the coast of Peru as a permanent replacement of the cold Peru current. El Nino occurs at intervals of about 3 to 8 years. At the occurrence, a remarkable disturbance in ocean and atmosphere occurs. It begins in the East Pacific Ocean and spread its effect widely over the globe. This disturbance lasts for more than a year, bringing droughts, heavy rainfalls, and severe spells of heat and cold. Periodic and local winds. Periodic and local winds developed as a result of variation in the local temperature, pressure, and humidity. Their origin is also attributed to the formation of air currents crossing mountain ranges, valleys, and physical barriers. The main cause of the development of local winds are: number 1, unequal heating of land and sea resulting into land and sea bridges. Number 2, heating and cooling of the mountain slope. Number 3, local winds originating because of the deformation of air currents crossing the mountain ranges and physical barriers. Number 4, convectional local winds caused by steep pressure gradients and steep variation in local temperature. The periodic and local winds are of great meteorological interest as they directly influence the health, efficiency, and economic activities of the people of the region concerned. These winds also influence the standing crops, orchards, vegetables, fruits, and flowers. And with this, I am ending my today's class. Goodbye.